I want to thank everybody for coming today and for coming to see me specifically. I hope everyone's RubyConf has been as great as my RubyConf has been. Probably one of the more exciting conferences I've had a chance to be a part of recently. My name is Brian McElaney. I'm the Senior Vice President of Technology at Think Company. Think is a user experience design firm in Philadelphia. It's a lot of business-minded designers and developers, project managers, working on things like design systems, product design, and things like that. I'm not here to talk about my time at Think Company. Most of the stories I'm going to tell today are about my early days as a dev lead, making decisions that seemed like the good choice to make at the time, but maybe didn't work out for me the way I thought they would. I should say I'm going to name one company today. The rest of them I'm trying to obfuscate a little bit. But there's a bit of a Dilbert effect to this, too. Nothing I'm going to say today should wow anybody. These are things that all of us sort of experience, and the goal of this talk is to start to form a vocabulary around talking about these things so that we can name them and by that have power over them, right? I should also ask, please bear with me. This is kind of a terrifying talk to give because this is 7 of my biggest blow-ups as a dev lead. So when I use words like we or us or they, keep in mind I was a key part of all of these decisions, right? I'm not trying to disown any of that. I've had kind of a unique career as a developer in that I've worked in a lot of different contexts in the industry. I've worked as a consultant, so people sold my time. I've worked in product companies, so people sold the things that I created. I've been on internal teams, so it's kind of like overhead, like electricity to the workings of the business. I've been on wildly overfunded and wildly underfunded projects. I've been in giant enterprise organizations and tiny little nascent startups. And throughout all of that, we found ways to make software go wrong, right? It kind of, like none of those factors really seem to matter to making things succeed. So I want to talk about one that did succeed. But it's my tale of tech debt. I used to work at this company, a motorcycle parts and apparel firm called Rosilla, and we merged with another company. And we were trying to figure out how to iron out their e-commerce experience with ours, and we realized that they had this giant enterprise e-com platform, and it was just never going to do what we wanted it to do. So we decided we're going to build a new one from scratch. Furthermore, we decided to do it in a language that none of us knew, using a functional programming paradigm instead of an object-oriented one. I got sick, ended up in the hospital for several months, and then came back and coded on painkillers for a while after that. I was one of the main leads in this project. Another one of the leads quit, right? So when I say everything was kind of stacked against us on this project, it's because it was. So we came up against deadline, and the CTO and I are having my one-on-one, and he asked me, like, how do you feel? And I said, horrible. This is a horrible idea. This is a giant pile of bugs and tech debt that we're calling software we can't launch. He says, whoa, 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 slow down. He said, are there any security problems? I said, well, not that I know of. And he's like, what about like performance? Do we have to worry about like memory leaks? And I said, no, I think we're good there. So he starts naming things like that. And finally he says, you know what? This is just tech debt. This is how people launch software. It's fine. Hit the button. And so I hit the button on the largest amount of tech debt I ever knowingly placed into production, right? Here's the thing. The guy was right. I was wrong. Right? What he saw and I couldn't was that I wanted like 2 more weeks to fail to make this better. That was really what I was asking for. This guy saw that the increase in revenue of switching from the old platform to the new one was going to pay to double the size of the dev team. It was going to pay to spend 6 months refactoring the software to make it right. He was able to see the business where I couldn't. I was looking at cost. He was looking at bottom line, right? Tech debt is our shortcomings, debts in general on projects, are shortcomings we accept in order to ship. And they're not bad things as long as they're managed. These things had to be managed and paid down over time. But I also wasn't wrong, right? Tech debt has destroyed the experience I've had on a lot of projects. But in the years sort of after this, this experience, thinking about it, I realized, like a 10,000 line method, that's easy to point at and say, this is bad for my code base. Or a big pile of a rat's nest of if statements, that's bad for my code base. It's easy to point at those things, but then I don't think they've ever destroyed a project I was on. If you define failure as the product never seeing the light of day, but I have seen projects not seeing the light of day, right? So what I realized was that not all project debt is tech debt. Process debts have killed most of the projects I've been on that didn't succeed, right? And debt works like friction, right? You don't stop a train by applying a ton of pressure to one wheel and hoping it'll stop. You stop it by putting little bits of pressure on lots of wheels, and over time it'll grind this behemoth to a halt, right? So that's what we're talking about here. None of the things I'm going to talk about today by themselves are necessarily dangerous to your projects. It may not be great, but there's shortcomings that we can sort of accept, right? But if you don't manage them, then it has the potential to take a project and stop it from launching. All right, so we're going to talk about this through the lens of the 7 deadly sins. This is not a religious talk. I'm looking at these as sort of a lens about unproductive behavior. And we're going to talk about each of these things in turn, and there'll be a story that kind of goes with each one. Right? So our first one here is anger. Anger is a strong or hostile reaction to a perceived slight. And perceived is important here. Right? It doesn't have to actually be a slight. We have a lot of things that happen to us on projects. We have budget pressures. We have time pressures. We have prestige pressures. We want the client or our customer or our stakeholders, the users, we want them to think that we're good at our jobs. Right? And so all of these pressures make it so that when we work together as individuals, or most especially as teams, that friction will eventually start to grind things down if we don't have somebody sort of orchestrating, those various needs to get things done in a way that's productive. So years ago, I was on a project. It was a big reinsurance company. So this is an insurance company that insures insurance companies. And they wanted a BI tool to be able to look at risk over time. And so there were 6 teams involved. There was a data cube team, data science team doing nothing but data cubes. We had a DBA team that was working on a bunch of database stuff. We had 2 app tier teams working on various parts of the business logic. My team was front end and data visualization. And then there was the SharePoint team. I guess that counts as software. And so all these people were coming together and they're trying to get these things done. And we sat down with the PMO, and the product owner said, hey, look, we probably need to move faster than all of us together can go. So let's all go off in our own corners. We'll agree on kind of what the contracts are and the APIs between things, and we'll come back together and we'll integrate this at the end. I'm sure many of you have heard this lie that integration, it'll take like 3 days, it'll be fine, right? So I go away for 6 months, come back in at the end, and I walk into this customer's office, and within the first hour, 3 developers from the other teams on the project asked me to review their resumes. I thought, there's something wrong here. I have to find out what it is, right? So I started looking into it, and what I found out was there was a requirement everybody kind of missed. Not that they missed it, everyone knew it was there, but everyone decided it was going to be somebody else's job to figure it out. It was basically a t-shirt sizing for risk, right? It was wind risk, which involves like the height of a building. And if you draw any sort of circle over an area, say in Nashville, depending on what block you drew that circle in, tall might be very different between one part of Nashville and another, right? Including any other country, it gets real different again, right? And so this idea of t-shirt sizing was never going to work, and everyone decided someone else will figure it out, right? What we didn't have in the middle was anyone looking at those requirements and understanding how things were fitting out. Project went over budget for about 2 years before the client finally killed it and ended up buying a product instead of building their own. Okay, so it wasn't a bad call necessarily. Parallel work can work, right? But you need to have that conductor in the middle of the orchestra that's speeding things up and slowing things down, raising the volume on certain issues and quieting it on others, right? Without that person sitting in the middle, if you're just the violin section focused on that, you're going to lose step with the rest of the team, and that coordination matters. If you lose that coordination, you get coordination debt, which again, totally fine, right? But you have to plan to be able to fix that. On my team, we learn about this, or an object lesson for us is dragon boating, which is an interesting sport because what you have is 20 people paddling, and as long as they paddle at the same time, oars in the water, everyone pulls as hard as they can at the same time, the boat will move fast. But if one row starts to try to paddle faster than everybody else, the boat will slow down, right? And so that coordination, that moving together piece, it becomes kind of important in the sport. So in software, why does this matter? Well, it's because by the time you realize a developer has done the wrong thing, it's usually too late, right? The code's been written. Now, at best, you get some churn, depending on how large of a problem it was, right? So I love this Seymour Cray quote. The trouble with programmers is you can never tell what a programmer is doing until it's too late. In a real way, this is Schrodinger's scope. Any given task that I have in my project is infinitely large and infinitely small until I actually do it, right? This is why in Agile, we talk about points instead of hours, because we realize the velocity is what matters, maybe not so much how long something takes, right? So how do we get around this? We need to get in sync. We need to find ways to get us having shared priorities, shared values, and shared communication systems. This isn't about tools. Slack, Confluence, those aren't the answer, right? It's communication. It's a shared understanding, right? And so things that we recommend, visual feature documentation. It's really easy to misunderstand pros, especially if the people on your teams are coming from different backgrounds, different cultures, right? Iterative prototypes, moving from design to actual code as quickly as possible, and then hopefully placing that code in front of actual users to find out what you missed, Well-documented APIs. If you had the chance to see, hold on, the talk by Keith McMahon on Principles of the Awesome APIs, phenomenal talk about API documentation. And finally, a North Star design. You know, as we're working through iterations and we're building towards something, having this sort of like overall goal, hey, this is where we're all headed from a design perspective or from an engineering perspective, can be really important to getting everybody on the same page. Even if that's not where you ultimately end up. Again, it's about trying to figure out how to raise and lower voices, it's about speed people up, slow them down in order to make sure that we're getting software out the door. One other talk I wanted to bring up was Ivan Nemchenko's talk, less abstract. He talked about visualizing object-oriented programming, which was a great talk about low-level visual documentation, of how your code works. All right, so desire, an intense longing for fulfilling of emotion. Imposter syndrome is real. Sometimes you're standing on a stage talking about your opinions and how software gets made and you're freaking out, right? So this intense longing is something you can't prevent, but it is something that if left unmanaged, especially across an entire team, can really do a lot of damage to a business. So years ago, I was working on this team. We were working on a product. It was an environmental reporting application. And our stakeholders came to us and said, we want these things as far as like how content governance is going to work on this project. And we looked at the features and we looked at the way things mapped out. We said, we're not sure this is technically possible. Like this just might not be feasible. So our first step was to call in a few contractors and say, hey, do y'all know how this would work? And they responded the same answer, like, no, this might not be technically feasible. So we're like, we're not going to accept no for an answer. So 4 of us buckled down, 10 weeks, 80 to 100-hour weeks, and blew through this feature. We ended up figuring it out. We ended up not on budget, but on time for sure, right? And the project never ended up launching. Nothing to do with that, that experience, but that kind of like plays into the message here. So before we get to that wasn't necessarily a bad thing to do. And I know there's a lot of like talk in the community about whether or not working hard is a thing that we should be bemoaning or celebrating, right? But sometimes some efforts require a little extra effort. Sometimes a sprint can be really gratifying for me as an individual if there's buy-in, right? As long as we all can kind of see the vision, the mission, what we're trying to pull towards. But it can't last forever, right? Sprinting can't be your MO. Not sprinting, just sprints, but that moving fast, win sprints. Can't be the way you do everything. You have to have those breaks on the other side of those events in order to catch your breath and settle out. If you don't, you're going to run into a situation where people are celebrating the wrong things. And in the case of the example I just gave, we celebrated the win. We made a thing we didn't think was possible. Our boss looked at what happened and said, look how dedicated my employees are. This is wonderful, right? The client was happy. They got a thing they weren't sure they could pull off, right? But I had an entire team burn out at the same time. We blew every estimate we had for the next 18 months, right? That has a ton of damage to a business. What ends up happening is this thing I like to refer to as morale debt. You're trading emotional safety in the name of shipping, which again, in short bursts might be okay. But whenever you have a team that has morale debt, they still have that desire. My morale's shot, but I still want you to think that I'm good at my job. And so I'm going to be lying to myself as much as lying to you about what the efforts are to get things done. There was a great talk by Ernesto Tagworker on a similar topic, because morale debt doesn't just come from that kind of overwork. It comes from other places. His talk about the tar pit, escaping the tar pit, was great. But he mentioned, projects running over budget will do this to you. Taking forever to ship small changes. You've been on tickets that last over multiple sprints and eventually starts to wear you down. Sacrificing quality to increasing your tech debt and like knowingly doing that, accepting that can take a hit to morale, right? Again, none of these things by themselves are bad, right? But lots of little bits of these things will grind you down. You end up with this thing I like to call hope creep, right? You start thinking aspirationally, right? You start thinking about, when someone says, how long will something take? You'll say, I bet I can get that done in 10 hours. Instead of saying, okay, here are the steps of that, how long those steps will take. This will take me 10 hours, right? Because when you are feeling good, you're in a good headspace. Things are moving well. You don't have that grind. You're not in the tar pit. You can make those kind of gut calls and be right some or even most of the time. But if you're in burnout mode, you're going to be trying to be kinder to yourself than maybe you should be. And your estimates are going to sound like they're going to be shorter than they are. So how do we fix this? Big one is plan more granularly. right? I've always been a big fan of the no task should take longer than 4 hours. Get handed a ticket that's going to take you a week, great. First thing you should do as an engineer is sit down and figure out how to make that into half-day chunks, right? Because if you don't see that forward motion yourself, it's going to get in your head. It'll also let you know kind of where your velocity is. If you think this is going to take, the first step is going to take you 4 hours, takes you 8, then you know you can go to your PMO and say, hey, like, I was wrong, this is going to take me longer than I thought. You know, it's okay to fail as long as you fail small and make the failure interesting, right? Pair programming, mob programming, you know, getting out of that isolation that a lot of teams have where people are sort of heads down working by themselves. If you've got people who are burnt out, making them work alongside of others is a good way to sort of break that cycle. Shipping more often is a big one. You know, I've never met a developer whose morale couldn't be fixed by putting code into production and hearing users were using something they created, right? And finally, you know, reducing your velocity. Again, if you're doing a massive push, trying to get something out the door, you can't have that next sprint be normal. You've got to slow things down a little bit. Throw in a refactor sprint. On my teams, I try to leave the last 2 or 3 days of any given sprint for refactor alone, and we plan for that in order to give people that chance to sort of like ramp down after they've had, you know, more intense effort on something. And finally, a big one is go home, right? Like, in this, especially if you're in management, is maybe even more important to lead by example by going home, right? But self-care is a big deal. And, you know, I could talk about this from the empathy side of things and say it's important to treat people well and make sure that they're taken care of and all these things that I honestly very much truly believe. But also, you can lose a business if you don't. Burnout is wildly expensive. I try to avoid it at all costs. Envy, pain at the sight of another's good fortune. I'm going to take a little bit of a twist on this one because it was the hardest one of the 7 to sort of like figure out. But instead of envy, what I want to talk about is this tendency for developers to think of the users as others, right? Or labeling users favorite users and not favorite users. So my example for this one was a large transportation agency, think buses and trains. And they wanted to reach out to a younger market. They had these, you know, this next level of college kids are coming in and they don't understand the train system as much. And so the starting point was to say, how do we teach these, you know, up-and-coming commuters how to use our system so that they know where they're going? What they weren't able to see was that train schedules were created, you know, hundreds of years ago, really haven't changed much. And they're thinking of like, hey, we'll just teach people how it works. It doesn't really like line up with the current reality of how people use software. So I tried to explain this to the stakeholder, and they didn't get it at first. And then I pointed to the train schedule that was sitting in front of them. I said, look, you have it printed out, you have the station and the times highlighted, because you can't look at it and figure it out either. And it's one thing to say you want to teach other people how to do the highlighter thing, but if I'm commuting to a new town, you know, I pop to Minneapolis and I walk in and I don't immediately figure out how public transportation works there, I'm assuming they have it. My first step is just to call Lyft, because I have this magical little plastic cube in my pocket that I hit a button and the car appears before me. It takes me where I want to go, right? So from a business perspective, it's pretty easy to talk to the stakeholder and say, hey, this is vital. This is existential. Like, you need to fix this problem and make this easier to understand, or you're going to lose your business because these other competitors are coming out from left field. But for an engineering team, that's a hard conversation to have. By the time you've taught your engineers that it's okay to say things like, we're never going to translate that. I can't tell you how many times it's blown up on me. Or, you know, we don't need to worry about accessibility, right? You know, this idea that, you know, context doesn't matter for engineering can be really hard to train out. Now, we need to limit scope, right? We can't do everything for everybody, right? But at some point, we need to figure out, you know, what's the logic razor we're going to use to figure out what things we should be worried about and in which order, right? The thing you're trying to guard against is empathy debt, right? Empathy debt is what happens when your development team starts to think of users and user contexts as I just totally lost my line of thinking, I'm sorry. When you start to think of your users as edge cases or stress cases or user contexts as edge cases instead of workflows as edge cases and stress cases. This can be cute sometimes, like the time I was sitting on a commuter train trying to learn Spanish, and I had to say out loud into the speaker that I was a little girl and I liked milk and Spanish, and a bunch of people on the train kind of looked at me funny, right? But in other places, this is less cute. Like on airplanes, when an engineer decided that a pilot should be able to figure out in 14 seconds whether or not that alarm was real or a test before the plane crashes, right? We see this stuff in the news all the time, right? And somewhere between a plane crashes because of a lazy engineer and ice cream, I'm a little girl, I like milk, is where pretty much every use case problem you have sits, right? So we need to find ways to make sure that our engineers are understanding that these user contexts are important and are really the point of the software. We don't build software to put things onto a machine and have them work. Well, I mean, some of us do, but not all of us. And so this idea of building empathy into our teams becomes real important. So how do we do that? One is building diverse teams. There's a guy, Alan Aldrich from Elasticsearch, and he once said at a conference that diverse teams make decisions slower, but the decisions they make tend to stand the test of time. I really like that sentiment, and it's totally worked out for me in my career. Building user validation into the schedule. I think a lot of teams think of user validation as a thing that designers do to wireframes. I like to do it to my code in production, right? Big fan of the Lean UX book, Jeff Gotthelf. His concept that every Tuesday should be testing Tuesdays, and we're gonna have users go and look at whatever is done in the last week every Tuesday, getting that sort of rhythm into things. And maybe most importantly out of these, because of the context of what I'm talking about, is having your developers participate in that user testing. It can be devastating to spend a sprint or 2 sprints on a feature and then sit down and watch a user fumble through it because it's not usable, right? But it's also very instructive. And again, this hits back at the desire thing. I want my users to think I'm good at my job, right? And if I can see them not thinking I'm good at my job, I'm more likely to really care about fixing that problem, right? Gluttony, overindulgence, particularly as a status symbol. This is my sin. I'm a big fan of this one. But as a status symbol is kind of the important part here, right? It's not that sometimes I eat too much kale, right? It's that sometimes I order a giant steak because I'm trying to show off for somebody, right? So in this case, this particular company was a logistics service provider, and they had these tool chains to sort of build these things out. And they had an engineer who was like me, actually. Went to a lot of conferences and heard a lot of different things. And this was, probably 2008, 2009. So it was at the heyday at Ruby conferences. We had people like Jim Weirich and want to get up on stage and talking about all these amazing design patterns that we'd never heard of before. And a lot of us got really excited and went back and tried them out on our projects. But this was a giant project. This is 300,000 some odd lines of code, right? So when people would come back and start adding these extra voices, these extra patterns into the project, it might improve a piece of it, but it wasn't being reflected throughout the entire system. Over time, what ends up happening is that these small differences become voices in the software, and then when you're trying to make changes to workflows, you've got to keep popping your head in these different contexts and thinking about these things in these different voices in order to get anything done, right? It's not that improvement is wrong. We need to always be making things better, right? That first year when I started getting into competitive cooking, I ruined probably a dozen briskets trying to figure out one that made sense, right? But that iteration has to get reflected through the entire system, otherwise it's going to become another friction that's going to slow things down, right? Put another way, that boot there might be the better shoe to wear for whatever I was doing that day in the city. But if I don't have the time to switch both shoes, then that's a problem, right? It's even a bigger problem, but the reason I put the boot on was because I was trying to be fashionable about it, right? If I put the boot on, I realize I don't have time to do both shoes, and it's just because I'm trying to be fashionable, I need to take the boot off, put my sneaker back on, right? So how do we start figuring out what these things are? It's hard because, again, there's a lot of these other sort of pressures that are involved in our day, right? I'm a big wine guy, I'm a sommelier, and I got this jar of corks, and you can go to Target and buy a $10 box of corks and have as many corks in your kitchen as I can, right? And if you want to show off like I do by having these corks in your kitchen, that will work to some extent, right? Work for some definition of work, right? But losing that understanding of going through the effort and getting things done is going to start to tear away from your ability to show off when your friends come over because they start asking, what wine did you drink most there? And your answer is, cardboard box. It was really good. So we need to start peeling apart when we're doing things because we're trying to show off from when we're not. We also need to start pulling apart when we're being experimental, which is important. It's going to teach us things and hopefully make our software better, and when we need to make sure that same is better, right? Keeping things consistent throughout our application in order to maintain velocity. So first thing is define patterns and stick to them, and we'll come back to this one in a second. Second one is leaving refactor time. I mentioned that earlier. On my teams, we try to leave the last couple of days of any given sprint for refactor time. But that's so we can all kind of get together and talk about the patterns that we came up with recently. Where can we reflect these patterns other places? Are these patterns things that we can make use of? And if not, is it okay to leave them there? Do we need to roll them back, right? And then the big one is bringing the entire team in on architecture decisions, from the most junior individuals in the organization to the most senior. I like this concept, Young's hierarchy of pull requests. John Young is the guy who came up with this for me. At the break fix level, everyone should be able to just commit that. You know, I mean, like you get a code review, but we don't need a giant conversation about how a break fix works. But when I start like satisfying a ticket, I probably want a little more conversation about how that's going to happen. Make sure that my idea of how this works makes sense, that it's the most efficient way things can be done, that I'm following established patterns that they're established. If I'm creating a new pattern, then I start to pump up to that next thing. If I'm resolving a code smell, hey, the way we do things right now is not right. I want to try this a different way. Then I probably want to get not just people code reviewing me, but making sure I talk to people before I start resolving the smell, right? Having more input on both ends of that development experience. Finally, if I'm introducing a completely new architecture, you know, hey, I'm going to tear out this hunk of the application and rewrite it in a lower language to make things fast. That's probably a conversation I want to have everybody involved with, right? At the beginning and in the end. Because even if you're the most junior person in the organization, you don't really have an opinion on how things work, you're going to learn a lot by hearing why people made the decisions they did and the process they did to come to the architecture that they ended up going with. Greed, an insatiable longing for material gain. We work in a capitalist society. Greed is totally required for most businesses in order to get things done. But I feel like the way we think about money sometimes can be a little bit anti-productive. In this particular case, I was working for a giant retailer of consumable goods. Think film, you know, things that are going to expire. And they have a giant warehouse full of this stuff, and they have a customer service department, and they're sending things out to their customers. And I was there trying to help them decide whether or not to build software to communicate better between customer service and the warehouse. And the line they had was, we don't have money for this. Like, there's no budget for this. We can't afford this software. But it didn't take a lot of digging to start to realize that there were some chinks in that logic. One of them was they had a problem where every time a customer would call up and say, hey, the film that I just bought is bad, customer service would immediately alert the warehouse that would immediately send out another roll of film. Great, totally makes sense. But there was no data capture about how often that happened on a given product. So if a manufacturer sends you an entire crate full of bad film, you just keep sending out bad film over and over and over again until you finally catch one that works, which is not just messing with your customer's head, it's also costing you a lot of money, right? So I mean, that's a specific example, but it kind of gets to this point. Cost cutting isn't the only factor. How much something costs is not the only factor in how we look at the value of our software. The value streams in your business have to matter as much. I mean, if you think about it, I forget what the study was that talked about it, but it was something like 60% of software projects fail. Call it 20%, whatever number you want to come up with. You know, a lot of software projects fail. You should be at least as concerned about that as you are with how much something is going to cost. Doesn't mean spend money, you know, senselessly, right? It means that we need to figure out how to measure our efforts. If I have more design time and that reduces code churn and make sure that I'm producing the right thing and increases my, you know, whatever statistic I'm trying to get at, you know, my conversion rates, whatever it is, then I need to start looking at the entirety of that math equation before I decide something costs too much to be able to do. We see this a lot in refactoring. How many times have you heard, I don't have time to refactor, we have to add new features? Well, if you did the refactoring, the features would come in faster. So at some point, that scale is going to tip and you need to start moving that direction. We wind up having a lot of politics-oriented development in this industry. We have a lot of people who don't understand what we do, or tangentially understand what we do. They know they need an effect, but they don't understand why things take as long as they do, or why they cost as much as they do, or why they can't accomplish some things. And so we tend to fix that in the work stream. We'll start writing tickets in Jira that sound right to a stakeholder, but might leave a developer looking at what is a 60-point ticket anyway, right? You know, you can't organize your code such that the least experienced or least technical person in the organization makes sense and have that be like the only way to do it. You need to communicate to the stakeholders, communicate up to management. You need to figure out how to get those communications going. And that's where like visual requirements really start to shine and make sense, right? But when you're organizing your dev efforts, you want to do that based on what's going to increase your velocity, not what's necessarily going to make people who don't understand and aren't interested in understanding more comfortable. No budget's limitless. And I think Agile takes a huge knock because people have trouble thinking about things in terms of velocity instead of cost. But if I tried to paint this sign, it would have made a lot more sense to just paint the oyster part of this and call that MVP and see whether or not the people down the street were able to read the sign properly and see if that worked to some extent, than painting the bottom half of this sign. Because painting the bottom half of the sign, I didn't get a completed product. You know, I didn't really ship something useful. I also don't know what the cost of the top half of that wall is going to be. What does this cost when I start having ladders and scaffolding and everything else, right? We have similar things that we do to ourselves in software on a pretty regular basis. So we need to stay lean. Prioritize business value. Do everything you can to tie your efforts back down to the bottom line, which can be hard, especially if you're an internal team member. If I'm making a product, I can say, oh, did work on this feature, that feature came out this fast, that caused this much more revenue in the year. You can do that math pretty easily. But if I'm an internal developer and I'm working on warehouse software for the retailer that I already work for, it's harder to see what the impact on my bottom line is for that. Strive to do it anyway. And then finally, stay agile. Be concerned with organizing your work so that your velocity increases, not necessarily that you know when things are getting done more regularly. It can be hard because the politics of these things can be difficult to sort of mediate. But again, if I have a burnout team because I pushed really hard on something, and that next sprint is going to be something that's really difficult, I need to have the hard conversation with the stakeholder and say, look, there's this other sprint, 3 sprints down. I need to pull all that work forward and push this back to give the team time to sort of like relax so I can maintain my velocity through the rest of the quarter. Pride, an irrationally corrupt sense of one's personal value. I'm a big fan of the 10x engineer concept for this. I worked with an individual, this was another e-com platform. This individual was crazy prolific, was able to write code much faster than everybody else. And so they picked this individual to write the 3rd iteration of this platform we were working on. And they did, and so they were the only ones that had the context. And I didn't really understand why this went south. I didn't have the context. The Jessica Kerr's keynote the other day really kind of illuminated this for me, right? The problem was he was the only one that had the context on a several 100,000 line application that this individual largely wrote by themselves. Then we start taking this product and saying we're going to implement other systems on top of this framework. So we have other developers coming in trying to understand the context of this application. But then this super prolific developer starts rewriting the context. To him, it's refactoring. He's just making the thing better, and he needs to do it in order to make this the best possible product it can be. Totally makes sense. But if everyone else is losing context as they go, it becomes problematic. It didn't help that this individual thought that they were above code review. So as they're changing context, nobody even sees the logic and the reasoning behind what they're doing. The person would go away on vacation, come back, had completely rewritten, say, the accounting platform within our system, and suddenly we've got mounds of tech that everyone else is trying to pay off. Not really ideal. But that individual's not wrong either, right? That speed is important to teams. Having fast developers is not a bad thing. Every relay race needs that anchor, that person who's going to bring it home at the very end of the race. But as Jessica had said in her talk, we need to figure out how to get that person into a position at some point in the process that individual is making others around them faster. The danger here is what happens when you start to let this person have certain leeway because they are the good developer or the fast developer or the experienced developer they are. Suddenly, you have these fast context changes, which we talked about. We have bad behavior. People who, we say no assholes except for that person because, we can't get rid of them. They're too fast or they know too much about our business, right? You can't make those exceptions, right? And finally, the code review exceptions is huge. This idea that somebody can write code and is above reproach because no one else understands Ruby better than they do. Right? We need to push back against that. I think a big part of that is because code reviews can be a huge source of education for everyone around us. I'm a big fan of using code reviews as a way to teach others how people think, more so than defect resolution. Hopefully all your defect resolution happens before your code hits GitHub anyway. Right? An education-oriented culture. Sometimes this is providing the ability for people to come to places like this. Sometimes it's starting a book club within your company, however it is. Because what will happen is these individuals who used to be seen as the pinnacle of the organization because they were fast, now have to be seen as someone who can teach people in order to maintain that same level of stature. Right? Their pride is going to start to work in on that. And finally, value simplicity. I'm a big fan of this picture. I saw this at the train station that I was coming into. And this kid was able to commute to the train station on the bike, lock the bike up with the helmet and the whole bit, replicating what their parent had done to get to work, because that pattern was simple enough to follow. We just tried to have software that the junior-most person on our team can follow. That's the reason why I'm not a big fan of metaprogramming. It's not because metaprogramming is necessarily hard for me to figure out. It's hard for me to take that context and load it into the most junior person on my team's head when they first start. And it's okay to have that debt, but I need to know that that's going to slow down velocity for that individual while they catch that context. And while I've got people training up on things, I probably want to kind of leave them alone until people catch up and catch that context before I start trying to move things forward. All right, last one, sloth. Sloth is about working in, not moving without care. It's not about being slow. I was moving pretty fast at the time. I was playing tag, ice skating, and broke my coccyx. This guy, Mark Platt, used to work with, he used to say, don't move faster than the speed of good ideas. And in that context, it was in cooking competitions. And he would watch me. I'm a fast cook, but he would watch me. And at some point, I started to move faster than my ability to keep up with what I was doing. And what he was saying was, he wasn't saying slow down. He was saying, like, hey, be mindful about what you're reaching for and where you're going. And typically that happened just before I burned myself on something. This company was a healthcare product company. If you've ever been on a healthcare project, you have to go through med-legal review. These things typically take like 7 years to get software out in the healthcare industry. And so the problem we had on this project was we kept running these cycles where we would start building, the core of the platform. Oh, we're going to build all these connectors to bring all these, healthcare devices in, and then we'll figure out what we're going to do with it later. And then we get to the next step and we'd say, oh, well, now that we've got all these connectors, we'll figure out a monitoring system. And every time we would sort of like move the project forward a little bit, someone in the organization would look out at the rest of the industry and say, oh, we need to change the intent of the project. Well, if you keep doing that, you're restarting that clock over and over and over again, right? So we ended up with this rudderless project. Every 8 months or so, we were changing what we were doing and had to start med-legal review over. The project never finished. I mean, it ran for 12 years, and as far as they still haven't launched a product out of this team. Right? It's okay to cut corners, as long as your failure is interesting. I can look at this and say, hey, I got that outside window in a pretty good spot, and that square window doesn't work, but it's functional. Right? I eventually want to replace that, but I can see how people feel about the overall design now. Right? But what you don't want to do is start to make decisions that are hard to change before you make the decisions that are easy to change. This might be a little hard to see from the crowd, but those windows don't line up, right? So you can imagine how this happens. You build the walls on the inside and then decide where the windows are going to go and find out you were off by a couple inches, right? But it is much harder to change where the windows are than it would have been to relay out the rooms, right? So what am I talking about with this? Tackle your biggest risks first, right? And again, this is another concept that I took from Lean UX years ago. Continuous refactor, this idea that we always want to be paying down technical debt. I like CI, CD, CE, continual evolution as like that third step. Continually evolving your software towards something and making sure those changes make it to the entire code base. And finally, defer your hard decisions for as long as you can. I think a lot of teams, I can't tell you how many times I started a project and people start sketching the database. Like, you don't even know if you need a database yet. Like, let's ignore that for a minute. Figure out what the business logic looks like first. All right, so in conclusion, this is a building in Tromsø, Norway, and I love it because it contains most of this ship. But an architect looked at this and said, you know what? I don't care if the top of that ship is inside the building or not. So I'm going to leave that aside. But maybe that matters later. So I'm going to build this building out of relatively cheap metal and glass. But I wanted to make sure that this is a permanent structure. So I'm going to spend a lot of money on that retaining wall to make sure that it's going to stand, rising sea levels and everything else they have to deal with the weather there, right? They were able to look at this from an architectural perspective and consider what needs to stay, what needs to be permanent, and what can be more malleable, what needs to change. And they made their decisions sort of around that. I feel like we need to do more of that in software, right? Taking into account all the lessons that we talked about today, if you walk away with anything, it's try to be intentional with how you decide about these things. Anyway, I will be around at the reception after the conference today. I'm out in the hallway. I'm on Slack, both the RailsConf 2019 Slack, as well as Philly Dev. Anyone's in Philly or coming to Philly, you want to hang out, maybe go to the meetup, Philly RB there, please let me know. My company's Twitter is Think Company. I am McElaney, and you can find me on Instagram if you want to look at me eating and drinking wine. That's Mac in Philly. Thank you for your time, and have a great rest of your conference.